Great dear learners. In this video, you are going to learn investigation and modeling of Cambridge 0607 International Mathematics Paper 6. It's a full paper solving video. Now I'm going to solve February-March 2021's component number 62. Let's get into the video. So we are going to start with investigation as usual. It's enclosed cuboids. So in each case, the gray cuboid is enclosed with white cuboid. So the first question starts here. The diagram shows gray cuboid 1 centimeter cube gray cube is there, then all around that we have white cubes. So the enclosing layer of white cubes is 1 centimeter thick. So this makes the second cube with each of 3 centimeters long. So this is fully 3 and this is also 3. Then we know the total volume is 3 cube, that is nothing but 27, and inside we have one gray cube. If you subtract that, we will be getting that white cubes, that is 26. The second cube is enclosed in a layer of 1 centimeter white cubes. To make the third cube, there are now 2 layers enclosing the gray cube. So already 3 is there, here 1 and then here 1. If you are adding it, that side length is going to be 5. And number of white cube is, then the volume will be 5 cube, and then that we have to subtract 1 which is inside the gray cube. Then we'll be getting the answer of 124 as answer. Next is, for any cube made in this way, write down the relationship between the total number of 1 centimeter cube and then total number of white cubes. So here we can say that white cube is equals total cube minus 1. So now they have given the calculation. N refers that number of enclosing layers. Then L says that length of outer edge, so like how we calculated 3, 5, 7. Then W says that number of white cubes, how many number of white cubes. So if it's 1 and 3, for 3 we just have calculated it is 26, because that cube value minus 1, and for the second layer both the side will be adding and we got 5. At that answer what we have got is 124. Then for 3 it is 7, for 4 it is going to be 9, and for 7 it is 342, and for 9 it's 728. So the nth value, it starts with 0, so that you have to write it as 2n plus 1. And here what we are doing, we are just taking the cube and we are subtracting by 1. Next is, a gray cube has edge length 2 centimeters. So now they have increased the edge length from 1 centimeter to 2 centimeter. And totally they have covered with the 2 white layers. This calculation gives the number of white cubes when there is one closing layer, 4 cube minus 2 cube. Explain why this calculation works, because 4 cube is the total volume and 2 cube is the gray volume. So that's how it works. So we can say that the remaining, if you subtract both, we are getting the white cubes. So we can get that number of white cubes is same as total volume minus gray volume. So that's how this calculation works for this subdivision. And complete this table for a gray cube of edge length 2 centimeter. So now we calculated, if one layer is there, then length is going to be 4, and 4 cube minus 2 cube is the answer. And now if this is going to be 6, and if this is 6 cube minus 2 cube, that is nothing but 208. Then this is going to be 8, so 8 cube minus 2 cube, that is 504. So in general, what is that n value? Since we are starting with 0, it is 2n plus 2. Actually, what are we doing here? In all the cases, this value, which means 2n plus 2, we are taking cube, and from that we are subtracting 8, or 2 cube we are subtracting. So the next thing is third question. Complete the table for a gray cube of edge length 3 centimeter. So if the layer is 3 centimeter, then what we have to do? So initially that length will be 3, because 3 edge length is 3 here, so that it will be multiple of if one layer, if it has, then we'll be adding 2 layers in both right side and left side. So this 3 will become 5, then 2 will be 7, then 3 will be 9, 4 will be 11. So what are we doing here for the n? Actually, we are adding uh, 0 plus 3, I mean 2n plus 3. Then we know that what we will do it here, it's 2n plus 3, the whole volume. What we are going to subtract, this thing we are going to subtract, that is 3 cube, because now edge length has increased to 3 centimeters, so we'll be subtracting 3 cube. So a gray cube has edge length e centimeter. So we have to complete this expression. So for the first one, what we have got is it's 2n plus 1. So by using this, we can maybe practice. It's 2n plus 1 whole cube minus 1 or 1 cube. And for the second one, it is 2n plus 2 whole cube minus 2 cube. Then third one, 2n plus 3 whole cube. Just now we have seen minus 3 cube. And e, if it e comes, so 3 now 3 cube minus 3 cube, so the same way it's going to be 2n plus e the whole cube minus e cube will be having it. Next is the gray cuboid has edge length of 2 centimeter, 3 centimeter and 5 centimeter. Previously we have seen a cube, but now we have a gray cuboid. Find the number of white cubes when there is one enclosing layer. So if there are one layer enclosing layer, so right and left will be added by 2. So 5 will become 7. Then 2 will be added with 2, so it's 4, and 3 will be added with 2, it's 5. So 7 into 4 into 5, that will be subtracted by, because that is the total volume and we are calculating white cubes minus gray cube. Gray cube is 5 into 2 into 3. So this calculation gives us as answer 110. Next is a gray cuboid has edge length of a centimeter, b centimeter and c centimeter, as like now. And if it's a layer, what we will do, we will be adding one layer left, one layer right, so that this will become a plus 2. But here they mentioned there are n enclosing layers. So if it's one layer, 2, 2 layers, it's 4, 3 layers, it's 6. So multiple of 2. So now it's going to be a plus 2n. So I guess now you have cracked it. Yeah. So the lengths are a plus 2n, b plus 2n, c plus 2n. So the volume is a plus 2n into b plus 2n into c plus 2n. Why this 2? Because right left side only will make the changes in the length as well as breadth and then height. So in that we will be subtracting a, b, c, because that is the volume of the gray cuboid. If you subtracted, then that's what going to be the number of white cubes. So number of white cube is equal to, this is the answer. And the next thing, a gray cuboid has edge lengths k centimeter, and 2k centimeter. So it's a kind of gray cuboid like this. You just consider this. And now the gray cuboid has 8 enclosing layers of 1 centimeter white cubes. So it has 8 layers, each has 1 centimeter white cubes. The largest face resulting the cuboid has 546 white cubes. So how we will be calculating that white cube? So the total volume minus gray volume. We know that gray volume is k, k and 2k, but actually this is not the thing, because we are just looking at the face value. How many number of cubes are there? It's something related to uh, surface area. So one wall we are considering, they mentioned it's the largest face. Which way is going to be the largest face? That should contain this 2k. And if any one bigger side is there, so suppose if this is 3k, then 3k and 2k are the largest face, but other two values are just k and k. So it's 2k is the largest and any one can be taken. So if we are considering this as 2k and this is going to be the k value and this face is the largest face. So similar face is also going to be largest face, where this 2k is relating with this k, but it's okay if any one we can take for calculation. And 8 enclosing layers are there, so that this 2k, the outer layer or outer cube, is going to have the value of 2k, 8 layers, so 8 plus 8, it's going to be 16. That is this total length, I mean the outer length. Then this will be multiplied, because we are just getting that area, and in that what is this length is going to change. Again, this is also going to be that k plus 16. because even this is also going to be up and down maybe. So k plus 16, that is equals 546, because that is total number of white cubes. Now you might ask me that why we did not subtract the gray cube, because we are considering the largest face, which is the outer layer, outmost layer, maybe the eighth layer we are concentrating. If it's the eighth layer, then obviously you know that that's going to be the white cube. There are no gray cubes will exist at that place. So I'm just repeating it, since it is the largest face, so that is going to be the outer one, so that is what going to give the largest face, because it's all about the wall, the final wall. So in that only white cube will exist, no other gray cube, because the gray cube will be at the center at 2k in that side only, that gray cube is going to be there. So we are talking about the largest face, that largest wall, nothing but outer wall. In that outer wall they said it's 546 cube will be there. So if the base has started with 2k and 8 layers gives 16 additional cubes, and both the 2k and k, so 2k plus 16 and k plus 16 equal to 546. Now if you solve this, you'll be getting the value of k easily. Now the thing is, how are we going to solve it? You know that very well. You will be expanding this bracket and you will be writing the quadratic equation, and you will be bringing that 546 outside either by factorizing or else by using quadratic formula. You will be solving it. Now I'm going to tell you one easy method. So what is that easy method is, since you are allowed to use GDC, so just type the first equation. So the first equation as this one, then second one, you know that if right side is a constant, then you might say that as y equals to 546 is the another equation, and just find the intersection point. So if you find the intersection point, so just consider that 546 is the line, y equal to 546, and if you draw the curve, we know that it's a quadratic, so it's going to be the parabola. So it will intersect at this point. So if you draw this curve, and it is necessary to show not only in the GDC, you should show that evidence that you have got from GDC. So show your graph, and the intersection point is what k value, it is 5. So you don't need to do so many calculations in algebraically, but if you are interested, then you can do it, you can go ahead. Since we are able to and we are allowed to use GDC, then better you can go ahead with the left side one equation, right side one equation, then draw it, and accordingly you have to change the V window. That is nothing but the scale values you have to change to get the full graph. You should see the U shape, that is parabola, you should see. Then that one, if you draw it fully, then only that answers will be accepted, because you're just directly writing the answer with the help of this graph. So we finish the investigation part, we'll start the model. Let's continue doing modeling, and it is all about that enclosures for cats. Here they have given some of the formulas for volume of cylinder, volume of cone, and volume of sphere. Let's get into the question. Dorothy has two cats and is going to build an enclosure for them. She considers three designs. Design 1 is a cone and design 2 is a hemisphere. The cone and the hemisphere have the same diameter t. So instead of using radius as r, and here they are using the diameter d. So let's see. Show that the volume of the cone is pi d square divided by 12. So that volume is 1/3 of pi r square. R square h is the formula, but r is equals d divided by 2. So r square is going to be d square divided by 4 into h. And if you simplify it, you'll be getting the numerator as pi d square by h, pi d square h divided by 12. And the next subdivision is find the volume of the hemisphere. Write your answer in its simplest form in terms of pi and d. So volume of hemisphere is, we know it's 2 by 3 pi r cube. R cube is d cube divided by 2 cube, that is 8. Then if we simplify it here, 2 and 8 can be simplified. So we'll be getting the answer of pi d cube divided by 12. Next, write H in terms of d when the volume of the cone is equal to volume of the hemisphere. So volume of cone what we got is pi d square h divided by 12, and the hemisphere is pi d cube divided by 12. So 12 cancel, pi cancel, d square and d is getting cancelled, and h is equal to d is what we are getting. Find the volumes of the cone when h equals d by 2. So volume of the cone is pi d square h divided by 12. Now they gave the value of h is d by 2, so it's going to be pi d square into d divided by 12 into 2, so it's nothing but pi d cube divided by 24 is the volume. Which is smaller, the volume of the cone or the volume of the hemisphere? Volume of the cone is uh, pi d cube divided by 24 we have, and volume of hemisphere is pi d cube divided by 12. We know that the bigger denominator reduces the fractional value, so here we can say that volume of cone is smaller because they are asking which is smaller. So volume of cone is nothing but volume of hemisphere divided by 2, because if you divide this hemisphere by 2, then volume of cone and volume of hemisphere both will be same. So this is what we are getting. Next one is minimum floor area for sleep floor exercise area, then extra floor area per cat is given, then highest point above the floor must be 2 meter or more. So these are the conditions we have to keep it in our mind when we are doing the calculation. So the next thing is show that the total minimum floor area. So floor area for two cats is 8.6 we have to prove. So area is two cats. So for each cat it is 2 into 0.5 plus 2 into 2.8 plus 2 into 1. Then the calculator gives us answer that 8.6 meter square, and we proved it. The next thing is calculate the diameter that gives this minimum area for both the cone and the hemisphere. If we look into that hemisphere and cone, then we can clearly understand that both of them are having the circle base. So if the base is circle, then we can say that the area is pi r square. So pi r square is nothing but pi d square divided by 4. This area they gave as minimum requirement is 8.6 that we got from here. So what is the d value will be getting? So 4 will multiply that side. It's going to be 4 into 8.6 divided by pi. Then actually we are calculating d, so it's going to be square root of it. So the answer what we'll be getting in the calculator is 3.31 is the diameter. And we can see it in the calculation. If d is equal to 3.31, then let's see this next subdivision. Explain why hemisphere with this minimum floor area is not suitable enclosure. Because if you look at the diagram, you will be understanding the height is nothing but d by 2, or else the height is also radius r. So height is r. Let's see what is the height value we have here. So if d is 3.31, then height is nothing but r, that is nothing but 3.31 divided by 2, so we are getting 1.65, but which is less than the expectation. Because we want a 2 meter, you can see that here the highest point above floor must be 2 meter or more. So highest point above floor is here the radius. That radius we got is 1.65. If it is 1.65, it is lesser than the expectation, so that we are saying that hemisphere is not a suitable model. Therefore hemisphere is not suitable. Next one is Dorothy decides on a volume of 10 meter cube for the enclosure for the two cats. Use question 6a1 to find out the model for H in terms of pi and d. So 6a1 model is pi d square H divided by 12, and they said that volume is equal to 10, so we'll equate this with 10, and we are going to just find the model. So H is equal to 12, will go that side, it is 12 into 10, it is 120, divide by pi d square, we'll be having it. Next, sketch your model for H for 0 to 12 for the d value. We are getting the calculator graph, GDC graph as like this. Then find the total area of the enclosure when the height of the cone is 2 meters. So when the height is 2, what is the area they are asking? So first, if the height is 2, let's calculate by using the x calculate value. So in GDC we can find the x value for the respective two value. We'll find what is the x value is. It is 4.37 we are getting here. If this is 4.37, diameter is 4.37, then area, what is the area? It's a circle, so area is pi r square. R is d by 2, so it is 4.37 square by 4, because r is d by 2 and r square is d square by 4, and if you substitute these values we are getting the answer as 15 meters square. Next thing is, yeah, so here we are coming to the design 3, because in the beginning itself they mentioned there are 3 designs. So first and second design we have seen, then third design is half cylinder. It's a diameter d and length w. So even here the connection between that the designs are the d value. Use the informations on page 10 to write down the smallest value of d. Why the smallest value? What is the smallest value of d here? They did not give any length or breadth or something, but they gave the height must be minimum 2. So what is this height is? It is d by 2. So d by 2 must be minimum 2, because d by 2 is nothing but radius. So this height must be 4. So that is the minimum value, because if the 2 comes here, 2 into 2 is 4. Show that the volume of the half cylinder is pi d square w by 8. So we know that a volume is pi r square h, pi into r square is here d square by 4 into height is w here, but it's a half cylinder, so the whole answer we have to divide by 2, so that what we will be getting is pi d square w divided by 4 and 2. If we merge it, we'll be getting 8 as answer. Next, show that a model for W for a half cylinder enclosures that has a volume of 10 meter cube is, so this is the one. We got the model for the volume pi d square W divided by 8. So pi d square W by 8 is equal to 10 meter cube dimension, so that is equal to 10. And we want a model for W, so only W, if you keep it here, then 8 will go that side, 8 into 10, 80, and this pi d square will come to the denominator, and that's what actually we need to prove. Next thing is sketch the model for W for 0 to 12, the same measure they are asking. So if we use this equation, then we will be getting the answer. Here the same type of graphs, similar graph we are getting here. Yes, we did it. Then the total floor area is 8.6 meters square. Write out the model for W in terms of D. So what is total floor area, where it is connected? So don't panic, just go to the previous page. You can see here what is the floor is. So the floor is a rectangle here. So if the floor is a rectangle, then we know that what is the area is. The area is d into w. So let's go back to the question. So dw is the area. area is given as 8.6. 8.6 is equal to D into W. They want a W in terms of D. So W is equal to 8.6 divided by D. This is how we are getting it. This is length into breadth. Next thing is on the axis above, sketch your graph. Sketch your model from part D1. So in this, what is answer? We got D 8.6 by D. So that if you are drawing in GDC, we are getting the graph. So this is also similar, but it's going like this, and they are intersecting. Let's find the point what it is. It is 2.96 comma 2.90. Okay. Find the height of the half cylinder enclosed that fits both the models. So what does it mean by both the models? The height value for the two models, when it is same, it is at the intersecting point. So we have to find out the height is nothing but d by d by 2, because it's a half cylinder. So this is the r, or we can even say this is d by 2, but the respective d value is 2.96. so d is 2.96, but the height, that is nothing but r, or else you can we even write it as d by 2. It is 2.96 by 2. So we are getting the answer as 1.48 meter. So that actually we got it from the graph. Then write down which enclosure of volume 10 meter cube, cone or half cylinder do you think Dorothy should choose for her two cats. So here we have an option. You can check that the height is actually 1.48. The height of the half cylinder is 1.48. That doesn't fit in the requirement. So better we can go with cone. Why we are going with cone? So we can say that cone, because half cylinder has no enough height. You can check that here. The minimum height requirement is minimum, maybe that also you can write it here. Minimum height required is 2, but this, if you see that it is 1.48, it is less than our expectation, so that we are selecting our suggestion as cone. Yes, okay, then yeah, so it's over, and this is the easiest paper that I have solved, I guess, but it's new one. It's 2021's paper. Let's see how it is going to be in the next series. Thanks for watching. Subscribe to my channel. We'll meet in the next video.